some of these and give you one more day to kind of plug away at this, and we'll submit it tomorrow. First thing I want to talk about is these first 6 questions. And basically this is going to be a practice that we use for the rest of the year. And almost every question we do, okay? Every question will be different. Every single thing that we talk about in this class, every question will be different. And that's a little bit different maybe from algebra, because in algebra, you know, if I wanted to factor something, they were all like x squared plus 3x plus 4. And then the next one was x squared plus 6x plus 8. And the structure was the same. These 6 pictures are all a little bit different, okay? But what I want us to be able to do, and this is going to kind of maybe correlate back to what you did in the 3rd grade when you first learned story problems. When you first learned story problems, the first time you saw them, whatever grade it was in, 3rd grade, 4th grade, whatever, you didn't worry about solving the story problem. You worried about reading the problem and then going through and highlighting the important information. Remember doing that? Did you guys do that? Okay. And then you realize, okay, this is the important information. All this other stuff is extraneous. All this other stuff doesn't matter to the problem. So when I look at these, okay, what is the relationship between these two here? They're vertical, and if they're vertical, their measurements are what to one another? They're equal. Good. Okay? So we say 5x equals 150. Is that question pretty much the same? Okay? The algebra is a little bit more difficult, okay, but it's still the same. Same, right? Now we get down to these, and they look a little bit different. But let's look at the things that matter to us. If I were to do this, does that picture now become the same as 1, 2, and 3? That line out there wasn't doing anything for us. It wasn't creating any of the angles that they were providing us information about. So why use it? Why have it? Okay? So I get rid of that line, and it makes the picture visually less cluttered, and I can make the distinction that these two things should be equal to one another. We should be able to do that in thought. I don't need the fact that this is a rectangle. I do that, right? And now I get those two angles to be vertical, and I should be able to set them equal to each other and solve for x. Now, what is nice, though, is that if I do go back and realize, well, I was looking at a rectangle, and those are the diagonals of the rectangle, those lines that are intersecting to create those angles. Now we know that every time that we have a rectangle and they intersect the diagonals, vertical angles are created. Okay, that will be a component to some stuff in chapter 5 and 6. Again, here, do we agree that this stuff, that stuff, not needed, right? And we can set those two things equal, and that's as simple algebraically as question number 1. So that's something we can do. If we start scrolling down and look at these here, okay, these questions 7 through 9 are giving you the same exact thing as 1 through 6, just in a different format. They tell me measure of angle 1 and measure of angle 4 are these expressions, but what's the relationship between 1 and 4? They're vertical, right? So if they're vertical, what do I do with that 5x and that 2x plus 90? Set them equal, right? Same thing down here, 1 and 4, set that equal to that. And once you do that, my hopes are you understand, once you create the equation, your geometry is done. You have mastered the geometry. But what stinks about this is that, and this is in any geometry class, regardless of what system, Math Excel or textbook or whatever we use, every geometry class is going to judge you of whether you're good at geometry or not based on what you get algebraically as an answer. Okay? At the end of course exam, you could get that 8x minus 120 equals 4x plus 16 on the end of course exam. They never ask you to type that in. But that's the geometry. They ask you to type in the actual x value, right? Does that make sense? And that x value then proves, once you get that x value correct, it proves to them that you're a good geometry student. But if you get that x value wrong, we really don't have a clear answer whether you're a good geometry student or a bad algebra student. Does that make sense? Okay? Or if you're a bad geometry student in general, because then you got the wrong equation and obviously got the wrong x from that. So that's what I want you guys to kind of focus on and realize for this course. Knowing when you got the geometry right and whether the geometry or is it the algebra that's creating kind of a disconnect in your thought when we're struggling on particular problems. Okay. Now the next one's a little bit different. 9 is angle 2 and 3. So we'll look at angle 2 and angle 3. Okay, they are still vertical, right? Still vertical. So what do I do with those two things? Set them equal again, right? Different set of angles, but they're still vertical. But now remember what the question was. Find the measure of angle 1. I still want to find the measure of angle 1. So let's say, I don't know what the answer for this is, but let's say x ends up being, based on this blue equation here, let's say x ends up being 10. Doesn't that make this 20? What's the relationship between those two angles, though? Supplementary, right? Okay. So do you see how they gave you information about 2 and 3, and you use that information to create an equation that has no direct link to angle 1? You didn't use angle 1 in creating that equation. But once you get that result and you're able to plug that in and find specific values, you can then use another relationship with those values to find what you're really looking for. Does that make sense? It's almost like, I think it's kind of a game. A lot of these questions are, what can we ask you, and then what kind of like intermittent hit and miss type parts can we give you so that you can kind of wiggle your way through the problem and find an answer. Okay? And if you approach, like, anybody like riddles or brain teasers or anything like that? You guys like those things? Sometimes? Okay. If you're a person that likes those, I think you'd probably be a person that likes doing the geometry, likes doing the math problems. Okay. Especially if you take the approach that they're all riddles. They're all little games that we're being asked to kind of manipulate. All right. I have a lot of questions on this. So tomorrow when I ask you to input your answers, we're not going to input number 10. Okay? We're going to work through this one right now together. As we do this, so our answer here for number 1, whenever we have obviously a given statement, it's going to be what our given was, right? So angle A congruent to angle BDA. Now, if you go off of that 7, what happened there? If you go off of that sheet that had those 7 steps on it the other day, it said every time you write your given down, if there's any congruent statements in your given, we want to go to our picture and draw that in. So I go find angle A and find angle BDA in our picture, and we draw that in. Okay? The next thing we do, okay, it says vertical angles are congruent. That's the reason. So we got to come up with a statement. Well, which angles up here were the vertical angles that we'd be looking at? There's only one set of vertical angles up here. It'd be this angle here and that one there, right? Okay, well now, because they share point D, you can't just say point or angle D is congruent to angle D, because there's like 8 angles here that have vertex D. Would you agree angles 1, 2, 3, and 4 all have vertex D? Okay. Would you agree that angle there, that linear pair, okay, that straight angle ADC has a vertex D? Okay. This one here, vertex D, vertex D, vertex D. So that's an issue. So in order to name these vertical angles, I want to use 3 points. So C to D to E. So angle C to D to E is congruent to angle B to D to A. Now, if you had those back, if you went EDC and ADB, that's fine. It says the same thing. Okay, so the order of those can flip-flop. But that's because vertical angles are congruent. So now, I need to, if we go off that sheet, I think step 3 says, if you, in your following statements, ever come up with another congruency, you always got to actively add that to your picture. Now, here's the thing. This angle here and this angle here are the ones we're comparing in statement number 2. This one over here already had one mark in it, right? I can't undo that one mark by putting 2 marks in it or something like that. Does that make sense to everybody? That has already, in statement number 1, been shown to have one mark in it. So in statement number 2, I need to abide by it having one mark. So if these two are congruent, this one has to have one mark. Does that make sense to everybody? What I want to say here is I don't want to do this. Because if I do that, my picture now contradicts what is said in statement number 1. Because now if I look at angle A and angle BDA, do they have different markings in them? And that would be contradictory to the statement number 1. So they all 3 have to have one mark in them. And that's nice now. Because if they all 3 have one mark in them, that means all 3 of them are congruent, right? If I have 3 things that are congruent, what does it mean that I can do with any 2 of them? Or what is the statement I can make about any 2 of them? Yeah, they're all equal to each other, okay? So if I have 3 angles that are all equal, 3 angles that are in this group that are all the same, that means I can pull out any 2 and say that any 2 are the same. If you remember the discussion we had previously, that is the transitive property. Okay, if I put, 15 things in a bag, but I told you they're all the same, can you take any 2 of those things out and say that any 2 of them are the same? Okay. If I want to be real clear about it, I'm just going to write this real quick. Angle A was congruent to angle BDA. That was statement number 1. Statement number 2, if I write it this way, angle BDA is congruent to angle CDE. Do you see how this is an A is congruent to B, but B is congruent to C? So we can make the jump that A is congruent to CDE. Does that make sense to everybody? And that's the transitive property. Okay. If we were to, I think I've shown you doing it this way. If I take that and merge it with that line, the BDA overlaps. So then if I get rid of that BDA, I've just got A congruent to CDE. And that's what they're saying here. And that procedure, that process is the transitive property. All right, now the definition of congruence. This is kind of a procedural thing. Whenever I use the definition of congruence, and especially if this has already been done for us, this line here right here has already been inserted for us. Usually, if they're going to use definition of congruence, this line here is the previous one, but written this way as their measurements. We know that if 2 angles are the same, then their measurements have to be the same as well. Now, at this juncture, this question is similar to, I think, the very first proof that we did it with segments. Okay, but if you remember back a week ago, we started first doing some of these proofs. We had segments that said maybe like distance AB is equal to distance BC. And then in our picture, they had algebraic expressions for AB and algebraic expressions for BC. And we replaced those things. So right here, what they're doing, if I look at measure of angle A, I come to my picture, don't they have a way that I can describe what angle A's measurement is? So what they're going to do is that in this statement here where measure of angle A was, we're actually going to replace it with 11x plus 20. That's its measurement. Here we have measure of angle CDE. If I go to my picture, it tells me what CDE's measurement is. And when I say it tells me what its measurement is, it's not very specific. It's not a numerical measurement, it's an expression. They tell me a way that I can talk about that measurement. So I'm going to replace that CDE's measurement with 12x plus 15. What is that process of replacing something with what I know it's equal to? Substitution. I don't necessarily agree that this thing has to be done in 7 steps. And these 2 steps can actually be flip-flopped depending on how you do your math. If I have 11x plus 20 equals 12x plus 15, what are you going to do first? Or what is an option? Okay, combine like terms. So I'd look on the left-hand side, no like terms there. The right-hand side, no like terms. But then you're going to start moving things over, right? So what would you subtract from both sides first? Oh, 11x? Okay, there's not a wrong answer here. I can move the 11x over, and that's going to give me 20 equals, what, x plus 15? Anybody move 20 over? So there's 4 different things you could do here. You can move the 11x over and get 20 equals x plus 15. You can leave the 11x where it's at, move the 20 over, okay, and get 11x equals 12x minus 5. You can move the 12x over and get negative x plus 20 equals 15. Or you can move the 15 over and get 11x plus 5 equals 12x. There's 4 different things you could write there. Does that make sense? Okay. If you went this route, but in each one of those, though, it's subtraction, isn't it? Okay. Whenever I move something across the equal sign, it's subtraction, always. Okay. But if I'm at this stage, then what would be the next thing to move over? 15, right? So it's going to be 5 equals x. And again, it would be a subtraction property of equality. Okay? Some people might say, well, step 5, I'm going to move 11x over to the right, and at the same time, I'll move 15 over to the left. And I'm going to get to 5 equals x right away. And that's fine because both, if you do those 2 algebraic steps at the same time, you're able to do them at the same time because of the same reason. Does that make sense? They're both subtraction. So if you want to do this in 6 steps and kind of ignore step 6, you could do that. I think, and this one wasn't too bad, but I think proofs in general, and you probably disagree with me because it's hard to initially think about starting them, I think, especially as a 9th grader, 10th grader. And we've only been working on them for a week and a half. My argument would be that proofs are easier when we have to do the whole thing by ourselves. Okay, logically they're easier. It might be more writing, obviously. Okay, but when they start filling things in for us, they're providing me a way that I have to do it. Does that make sense? Where if mathematics in general, if there's 6 or 7 ways of doing something, maybe I'm more comfortable with the 6th way rather than the 1st way. Okay. But when they structure it this way, I've got to do it their way. Now, it's not terrible on this one because there really is only one way to do this particular proof. But there are some proofs, like the Pythagorean theorem. There's like 79 confirmed ways of proving the Pythagorean theorem. So there are a lot of things that we can do multiple ways. And if they try to force me their way, maybe I don't think the way they think. Okay? And that can sometimes be a problem. These tended to be the ones that posed most of the questions throughout the day. Okay, and these are the ones that, for the most part, are why I'm kind of postponing putting this in until tomorrow. I'm going to give you a little bit more time to work on these. Before we get into these, I want to kind of explain something to you. And I think, I know you guys are intelligent, so you understand this. This is a geometry course, correct? We're not going to have time to get all the geometry done, okay? If that's all we were able to focus on, we didn't have to do any algebra, we still wouldn't get all the geometry completed to the degree that we need to complete it, okay? So now we throw in algebra, okay? And we forget some of the algebra that we worked on last year, okay? Forget some of those processes. I'm not sure what to do maybe in the systems equations. And I will spend time in class with you on them because I think algebra is something that we can't, if we get lost with it, confused with it, we can't just skip it because algebra is kind of the engine that drives mathematics. Without algebra, we don't have anything, okay? And I always make the argument to students, you guys, you hear people talk about calculus being really hard, right? Okay? You guys know what slope is? Okay? You know what area is? Okay? So you already know calculus. Okay? That's all you do in calculus is slope and area. We look at things and try to find slopes of things. We look at things and we try to find the area of them. Okay? That's all it is. Okay? Now, area evolves itself into volume as well. But that's all we talk about in calculus. But in order to do the calculus, it is very, very, very detailed and, in my opinion, difficult algebra that we have to use. Okay? Without that algebra, our calculus doesn't work, doesn't operate. Okay? Same thing in physics. I mean, gravity makes sense to us physically, right? We understand what gravity is. Okay? But if I don't understand how to algebraically use it, how do I understand forces and momentum and inertia and that kind of stuff without an understanding of the algebra to manipulate things? So, that being said, if you get to a point where you are struggling on algebra, you go to my website and you scroll down beyond the classwork, beyond the places that you can find your videos and all that kind of stuff for the classes, you get to this, okay? If you're a person that struggles with fractions, you click on that fractions, and it's going to take you to a link, okay, or to a site that's got endless amount of videos for fractions, okay? There's going to be interactives there you can mess around with to practice fractions, and that's going to be adding, subtracting, multiplying, dividing fractions, okay? If you've ever had trouble with unit conversions, which some of you are going to recognize this in science eventually. You guys work with moles yet in science? Okay, Avogadro's number, all that kind of stuff. Understanding what your units need to be before you do the problem might give you an idea of how you have to use Avogadro's number, okay, and how you have to multiply it. Unit conversions would be something there. We'll do unit conversions in this class as well eventually. Solving equations, no matter what kind of equation you want to come across. If I click on these, I have nothing in that one, so don't try to click on that one. I'll put some stuff in there, though. But factoring will be a key thing that we have to be able to do. If you remember factoring, things like ax squared plus bx plus c, these types of things, okay? That will be a key part of a lot of our questions that we do later on in the year. Okay, that's going to be the key algebra that we focus on. Systems of equations, that's what we're focusing on right now with these questions in our worksheet. If you struggle with systems of equations, okay, you click here, and they've got videos that circumvent any of the algebra, because circumvent any of the geometry, because you guys are going to have the ability to solve the geometry, set your relationships up. But then it's how do we solve those relationships? Lots of videos here to be able to do that, right? There's even more videos right here underneath these links. You guys do sig figs in science, just to kind of show you some stuff here that maybe is additional to what we're going to talk. We can do sig figs in math class, okay? But if you're concerned about sig figs, you can click down here, and it's going to give you a lot of things to do sig figs, and these are all practice interactives with sig figs, okay? Now, here's my thought. I put those there, and where I got all that stuff is from the internet, right? You have the internet without my website, right? But when I go to the internet as a 9th grader or 10th grader and I try to search for something, maybe I'm not 100% sure what I really search for or what to be looking for, okay? So I take the internet and I narrow it down to maybe 10 to 15 videos that are going to help you with those topics, okay? So that's kind of maybe the first place I would look if you're a person that says, I'm not going to be very efficient, or I'm not solving these correctly, and I'm worried about that. And you should be worried about that, because these things aren't going to go away. Systems of equations are going to be something that we talk about for the rest of the year. Okay? So those are there. Okay? Please use those. And I put those because of the idea that I can't do the algebra, teach all the algebra, and teach all the geometry at the same time. When I was in school, it was, you don't know the algebra, then that's your fault, and we move on, okay? And then you get left in the dust because you can't solve these problems because you don't know the algebra anymore. Now we have resources. Now you guys have the internet. Now you have my website. You can use those things, but they're only going to be useful if you Use them, right, Hunter? Okay. So which one of these you want to do? We already did number 11. 13? Last class wanted to do 13. All right, so we look at this. And we have to develop relationships. And this is the game. Nowhere does it tell me, it says find the value of each variable and the measure of each angle. It says nothing about how to do that. And it never will throughout the rest of the class. It's just going to give you the picture of the image that we've been working on, and you have to start thinking about what are the relationships. So tell me, what do you know about that angle compared to that angle? Okay, so if I know that that is true about any type of linear pair, then when I write 4y plus 2x equals 180, I know that's true. I know that that is a true equation. Now here's the thing. And I don't know if you want to write this down. I probably want it right now. But that's just one version of that equation, right? Is this another version of that equation? Is this another version of that equation? Is this another version of that equation? And is this another version of that equation? Does that make sense, everybody? Okay, and I can come up with all the versions. I can subtract everything from both sides and get zeros over here. You got a lot of different versions of that equation. Maybe some versions are better than others, whatever. I don't really care. I'm going to write that first one. And then we'll talk about, once I have that version, what am I going to do next? Okay? And here's the idea. No matter how I address that, no matter which of those 5 extra versions I look at, none of those will tell me exactly what y is or exactly what x is numerically. Okay? They gave me expressions for x. They gave me expressions for y, but they didn't tell me the numerical value for either of those. And that's what we're looking for here, right? So what do I do, or what do I need if I'm going to solve for x or solve for y here? Lexi? I need another equation. So I need another equation that says something different. Maybe we look at these two. What are those two going to tell you? Or what is the relationship between those two? They also add to 180. So I can say, I'll combine them as 3x plus y plus 10 equals 180. Okay. Now with these, I am a fan because I got a constant here and a constant there. I do think it is wise to move all those constants to one side. Okay. So I've got those. So now here's the thing. That is enough for us to solve this problem. You only need 2 equations with the same 2 variables. Okay? We talked a little bit yesterday that a third equation from time to time might be beneficial. What do we know about those 2 red angles? They're equal. They're vertical. So I might want to say 4y equals x plus y plus 10. And maybe the better way of writing that would be like 3y minus x equals 10. Does that make sense? Just moving all my x's and y's to the left-hand side and leaving my constant on the right-hand side. But those are 3 equations that we can use together to help solve for x or y. Okay? Now, this is a particular question which I don't know. We would have to time ourselves through the different processes. Whether using those 2 together with elimination or substitution would be quicker than using those 2 with maybe just elimination. Okay? I don't know if using those 2 will be faster using elimination, or will they be faster using substitution. Does that make sense? And I don't know if those 2 will be faster using one or other of the other techniques. Okay? But I do know that that right there, and maybe even that right there, is a nice thing. Okay? It's a nice situation occurring because it's a 1x and a 1y, right? If you remember from last year, the way you were taught to substitute, if you're going to use the substitution property, is to solve maybe this one for y. And you get 170 minus 3x. Does that make sense to everybody? Okay. So that says the same thing that these other two equations up here say. It's just a different format. Well, now that I know what y is, and I've solved for y, and I could have done that up in number 1, or I could have done it over here in 3. I just chose to do it here because I already had a 1 there. Can I take one of these other equations, maybe that one, it doesn't matter whether I choose equation 3 or equation 1, and can I plug y in? Now that I know what y is that now, right? Can I say that 3 times 170 minus 3x minus x equals 10? Does that make sense? I'm going to distribute. Okay, so 17 times 3 is 51. So that's 510. Minus 9x minus x equals 10. Combine like terms, and we'll move this 510 to the other side. So it gives me negative 500. Gives me x to be 50, right? Okay. So solving for y and then plugging it into another equation that had y in it will allow me to solve for x. Now, just to prove that it didn't matter which one I plugged into, if I go 4 times 170 minus 3x plus 2x equals 180, 4 times 170 is 680 minus 12x plus 2x equals 180. Those are going to give me negative 10x. When I move that to the other side, it gives me negative 500. Does that still give me x to be 50? Does that make sense? So some people will make the argument, well, I didn't know which one to plug it into. Choose one. It doesn't matter. Okay? Whatever you want to, it doesn't matter. Now that we have the x value, can I plug that x value, either one of them, because they're both 50, into this to solve for y? So y would equal 170 minus 3 times 50. So y then is 170 minus 150. Y is 20. And now if I want, now that I got x and y, I'll leave it up to you. You can substitute back in. You can find one of those angles is 100. The 2x angle would be 100. The x plus y plus 10 one would be 80. The 4y one would be 80. Okay. That's using substitution. And that's using substitution in one way. I solved for y equals 170 minus 3x. Somebody else might have used substitution, but they solved for x in that red equation. That's fine. It's different math. You have different equations and all that kind of stuff, but you still have the same x equals 50 and same y equals 20. Does that make sense? I don't know how many. There are so many different ways of doing this problem. I would probably say there's 40 different ways of doing this problem, at least 40 different ways of doing this problem. Because it depends on what variables you solve for, okay, depending on which two equations you use, depending on whether you use elimination or substitution. There are so many different ways to do this problem. And that's my argument to students of your age, is that we always want to show me the one way of doing this. And I think that's backwards. I don't think we should try to learn how to do this problem. I think we should learn how to do this type of problem. Does that make sense? Okay. And then talk about maybe various ways to do that type of problem. So and we use substitution. Let's go around here with elimination. One of those equations, that first one was 4x plus, was it 2y equals 180. And then we had the one, I'll use 3x plus y equals 170. 3x plus y equals 170. If you remember elimination, the goal was to add straight down, and hopefully we had basically terms that were opposite. Either the x's were opposite or the y's were opposite. We don't have that here, right? But one of the properties that we learned last year is that we can manipulate any one of these equations, either one of them or both of them, any way we want to through multiplication or through division. Okay, usually people like to stay away from division though. Okay, so if I want to get my variables to cancel out, do you guys agree that it would make sense to let those cancel? Because it's going to be easy to make this one 2y. If I was going to get these to cancel, what do I have to turn them both into? We'll have to change the 4x to 12 and the 3x to 12. So then I'd be multiplying both equations. Okay? But if I want to change the y, cancel the y's, that top one can say 4x plus 2y equals 180. And the bottom one, I want to multiply by negative 2. Because now that's going to make negative 6x minus 2y equals, okay, 170 times 2 is what, negative 340? And now I'm going to add straight down. That gives me, what, negative 2x's? Those go away. This here, okay, is going to give me, I'm sorry, this is 3, no, that's, right, 340. Huh? Did I write the equation right? 3x plus y equals 172, negative 6x, 2x. So 180 minus 340 is negative 160, right? X then is, that's not right. That should end up being, where'd we go, miss? 4x plus 2y. Oh, that's where. So I have 4y plus 2x, and right here I wrote as 4x plus 2y. Okay. I apologize. We'll fix it. 4y plus 2x equals 180. This is 3x plus 1y equals 170. Okay. I apologize. So, everybody okay with that? We see my error. This was 4y. Over here I wrote it as 4x. This was 2x. Over here I rewrote it as 2y. That obviously is going to throw everything off. So fixing that, now I look at these, and does it make sense now to try to cancel those? So let's try to cancel those. What would I multiply this bottom one by? Negative 4, right? So now, top one's going to be 4y plus 2x equals 180. The bottom one becomes negative 4y minus 12x. It's going to give me negative 680. Those are going to eliminate. I get negative 10x. That's going to give me negative 500. Does that still give me x to be 50 when I divide both sides by negative 10? And then to find y is just like the other one when we did substitution. You go find an equation that has y in it, substitute x to be 50, and evaluate for y, solve for y. I don't like, if I've got a choice, just a personal preference, I like substitution because I don't like to do multiplication a lot, especially with these linear pairs. I don't like that multiplication of 4 and 170, so I try to stay away from that stuff. We talked yesterday that you could graph those, right, and get the answer that way. Maybe down the road I'll show you how you can use matrices in a TIE 3 or 4 to get that answer. Okay. But here's the relationship in number 14. Okay. So 14 is the same thing, right? The same exact problem. And now you might, and here's where I fear that we're going to do this, is that we just kind of blindly say, oh, 3x plus 8 plus 5x plus 4y equals 180. And then I'm going to say, okay, well, 5x plus 4y plus 5x minus 20 equals 180. So I'm using those two to be supplementary and those two to be supplementary, right? And my fear is that you're going to say, well, Mr. Fay said it didn't matter which two of the three equations that we create, so I'm just going to create those two. I'm going to spend maybe 6, 7, 8 minutes solving that. Where if you would have taken these two and said that they are vertical, and you get 3x plus 8 equals 5x minus 20, how many variables do you have in that equation? 1. Is that much easier to solve? So solve it. You'll get x to be 14 here. Okay? Now I still need y, right? I still need y. So even though I wrote those two equations down on the left and I didn't need them yet, they are true, so I wouldn't erase them. Because now that I know what x is, can I plug that x in there? Or plug that x in there to solve for y? And that's going to be a much more efficient way of solving that problem. Nothing wrong with doing elimination or substitution in that one. But if I look at the blue angles and I create that relationship, I think it better serves us. Okay? Is that all right, everybody? Again, I want to reiterate, if you struggle with the algebra, you know that better than I do right now. Okay? And you know to what extent better than what I do. And I'll learn whether you know the algebra or not. Okay? And I'll start adjusting how we do things based off that. But you know that much sooner than I do. Okay? So my hope is that you do things to alleviate that struggle prior to it becoming an issue. Okay? Prior to maybe the next quiz or the next test or in 3 chapters from now when the stuff is used in every single problem. Okay? The geometry concepts overall, guys, throughout the entire year are not going to, hopefully you've seen that they're common sense almost already. It stays that way. Okay? So I think we'll have time to talk about the geometry and learn the geometry, and that will open up a little bit of time because they're common sense almost to go back and deal with things like factoring, systems of equations, working with radicals. Okay? Those are kind of the 3 main algebraic topics that people struggle with, and they're the 3 main algebraic topics that you'll need for Algebra 2 and for anything beyond that. Okay? So I will do my best to try to work with you on those, but at the same time, understand it's not an algebra class. So we got to do things on our own if we're lacking in those departments. Something that maybe you guys have seen in other classes or talked about in other classes, we have to sign out now to go to the bathroom. Okay? Wherever we're going, leaving class, you need to sign out, and then when you come back, you need to sign in. Okay? So currently,